Imagine trying to identify individual leaves on a tree from an airplane, or trying to understand the shape of a mountain range by looking at a single pebble. Both tasks requiring a specific level of detail to be meaningful, but getting too much or too little detail can actually make things harder. When it comes to geographic data, higher spatial resolution does not always mean better data. Instead, the usefulness of data resolution is entirely dependent on the specific application, the size of the features you want to analyze, and the overall goals of your project. Spatial resolution refers to the size of the smallest feature that can be detected in an image or dataset. Think of it like the pixel size on the ground. For example, a 1-meter resolution means each pixel represents a 1 meter by 1 meter square on the Earth's surface. The primary reason higher resolution is not always better is due to a combination of factors including data volume, computational cost, and the potential for increased noise. Acquiring and processing very high-resolution imagery generates enormous data files. These larger files demand significantly more storage space and powerful computing resources to manage and analyze efficiently. Moreover, extremely fine resolutions can sometimes introduce more noise or irrelevant detail, like shadows or small surface textures, that can complicate the extraction of the meaningful information you are truly looking for. For instance, if you are mapping large agricultural fields, a 5-meter resolution might be perfectly adequate and much easier to work with than a 10-centimeter resolution. To choose the right resolution, first, clearly define your objective. What specific features are you trying to identify, measure, or monitor? Next, consider the size of those features. If you are tracking large-scale deforestation, a coarser resolution like 30 meters might be appropriate. If you are mapping individual building footprints in an urban area, you will need a much finer resolution, perhaps down to 0.5 meter or even 10 centimeters. It is also important to balance the cost of acquiring the data with your budget and available processing capabilities. Professionals often seek what is known as the optimal resolution or the minimum mapping unit for their specific task. This concept emphasizes finding the sweet spot where the resolution is fine enough to distinguish the features of interest, but not so fine that it introduces unnecessary data volume or noise. Understanding this balance is key to working efficiently with remote sensing data, allowing for clearer analysis and more reliable outcomes. Ultimately, the goal is to use data that is fit for purpose. Selecting the appropriate spatial resolution ensures you have enough detail to answer your research questions effectively, without being overwhelmed by excessive data or irrelevant information. This thoughtful approach leads to more efficient processing, more accurate results, and a deeper understanding of the geographic phenomena you are studying.